Welcome back to part 3 of our 3-part series, an introduction to the 7 levels of processor measurements you need to master in order to do a processor analysis in the mainframe computing environment. Again, the processor is your most expensive and important resource, so let's make sure we can measure it. Now, if you've not seen part 1 or part 2 of this video series, click on the associated links to gain access to those videos and take a look at them as well. So welcome, and I'm looking forward to spending my time with you. So thank you for joining me for this third part of this 3-part series, an introduction to the 7 levels of processor measurements you need to master in order to do an effective processor analysis in the mainframe computing environment. Now, if you watched part 1 and part 2 of this video series, we talked about the first 5 levels of measurements that you need to master. To recap them really quickly is we want to understand the total amount of CPU time on our machines that are available to our workloads in our systems. The next level we looked at was looking at the CPU as broken down by each individual system image. The third part was looking at the CPU broken down to the logical partition level, so we have each logical partition and how that CPU is broken down. The next level we looked at was looking at the CPU at the MVS operating system level, also known as ZOS. And that's where we talked about the MVS captured time and the MVS uncaptured time. And we also talked about the next level down, which is looking at the CPU at an application level, at the importance level, at the workload level, just breaking it up to understand where the CPU is being accumulated on our workloads on our MVS operating system. During this video, we're going to be talking about the remaining 2 areas, and we're going to see that that is looking at CPU at the address space level and looking at CPU at the transactional level. The next level of CPU time that we want to analyze when doing a processor analysis is level 6, which I call looking at things at the address space level. On the MVS platform, on ZOS, all work runs eventually in an address space. For those of you not familiar with the MVS platform, think of an address space as a process, right? So we think of an address space as being a delineated sort of entity on the operating system where work will run. This is where our programs run, this is where we have storage, this is where we have our programs, our control blocks that are associated with that address space, and this is where everything really happens. Now, since all work runs in an address space, what we want to understand at this level is, given all the address spaces on my system, how much CPU time are they consuming? Now, if you have a workload, if you take all your address spaces, in theory, you take all the CPU time of all your address spaces, that should about equal the CPU time of all your workloads, which should about equal the CPU time of your MVS capture time. The point is, you can see we're kind of going at a more and more finer granular level of how to break the CPU time up. Why you want to look at work at an address space level? As I said, that's where the work actually is executing its instructions. That's where the programs run. So we want to understand things like, well, which address spaces are running? What are those address spaces doing? How much CPU time are each one of those consuming? Do we see anomalies of the address space CPU time? Maybe this address space is normally consuming just a little bit of CPU time, but today it's consuming a lot of CPU time. The point is, it's a more granular way of looking at things that eventually we can understand what address spaces are running on our system, which represent our workloads. Our workloads all have address spaces that we talked about. So that's at the address space level. So we're finally down to level 7, which is how we look at CPU time at what we call the transactional level. At this level of our processor analysis is we've gone all the way from the machine to the individual LPARs. We take the LPARs and break their CPU time up. We have our MVS time, we have our workload times, we have our address space times, and now below that is our transactional times. First, what is a transaction? Think of a transaction as a delineated unit of work. It is the transaction. It could be a keystroke on our terminal, it could be an ATM transaction, it could be anything you can think about as a unit of work that wants to run. Now, I have other videos where I talk about different types of transactions, because a batch job could be a transaction. As I said, a CICS transaction itself is a transaction. A database query can be a transaction. Transactions run within address spaces, but also transactions run in entities we call enclaves. Those are all discussions for separate videos, but just know that the transaction is the individual unit of work. Now, we have lots of measurements for transactions that, in fact, there's almost no shortage of transactions on the MDS platform for our individual transactions, because in this case, we want to understand every little thing that's happening and how much CPU time individual transactions are. So, for example, I might be a bank, and my bank, I might do, let's say, 5 million ATM transactions a day. Those 5 million ATM transactions a day is spread across all of my work, all of my day, my 24 hours. What I want to understand is what transactions are happening throughout the day, how much CPU time each individual transaction is doing, what are the issues with the different CPU times of the different transactions. Can I find trends to find out why certain transactions don't perform well, or why certain transactions use up more CPU time. The point is, we're at a very fine granular level here where we can actually start analyzing things into the application, into the code itself, to help us understand CPU usage. So the level we're doing here is the most granular level that we're going to do in this video, which is at the transactional level. Now, if you're into MVS diagnostics, I will say that you can go deeper and deeper, because we can do traces and there's all sorts of things we can do, but that's outside the scope of this particular video. So to summarize, level 1, how much CPU is on the machine. Level 2, how much CPU is being used by each individual system image and Prism itself to manage all the system images. Level 3, given a system image, how much CPU time is being consumed by that system image and its workloads, and how much CPU time is being consumed by Prism to do work on behalf of that individual system image. The next level is our MVS time, which is how much CPU time we can attribute to the MVS operating system and all the workloads. And then there's MVS uncaptured time, which is just that, uncaptured. We know we consumed it, we just can't attribute it to a particular workload. Below that, we have all of our different workloads. We can do it at workload level, importance level, application attribution level. Below that, we have our address spaces where the work eventually runs, and below that we have our transactions, which are the individual delineated units of work themselves. So that is the 7 levels of CPU time that you need to master when you want to do a processor analysis in the mainframe computing environment. So thank you very much, and as I said, if you are interested in this topic, in the references below, I will give a link to a paper where I talk about these different levels with some verbiage, but I'm also going to give you some measurement examples, or really where to find those measurements, what records, what areas you can go find those measurements in. And those 7 levels of measurements will be topics of future discussions on this channel, how to analyze them, how to break those measurements down even further, and what to do with them, and how to make sense of them. This concludes part 3 of our 3-part series, an introduction to the 7 levels of processor measurements you need to master in order to do an effective processor analysis in the mainframe computing environment. Now, if you're new here, make sure you click the subscribe button, and below there's also a link to a paper I've written that will give you a summarization of these 7 levels. Also, if you want to see part 1 and part 2 of this series, also there'll be a link below. So thank you.